Now we will study some important groups, some very important groups like roots of unity, addition, modulo, and okay. So let's start. So basically, some important groups. The first very important group that we will study, that is set of nth roots of unity under multiplication. Another we will study is a Zn. Zn. What is this? This is basically this is addition modulo. Basically, this is addition modulo n. I will tell you what this means. Don't worry. So these are some special type of groups. Let's start with roots of unity. Okay, so this is a very important group, roots of unity. Like what this means, like what this roots of unity means. So let me explain. So first you notice this. If I give you this equation, what are the solutions of this equation? For example, if I give you, okay, let's assume I give you x equal to 1. How many solutions for this equation? Tell me from here, what can you say about x? How many x will satisfy this? How many x? Only one solution, right? X equal to 1. X equal to 1. Only this is the only solution, nothing else. This is the only solution, correct? Okay. So can I say this is a group under multiplication? Can I say this is a group under multiplication? Is it a group under multiplication? Your base set has 1. In your base set, you only have 1. Is it a group under multiplication? Yes, this is a group, right? This is definitely a group, because what is the identity element? 1 is the identity element, and so you can notice. Okay, so if I have this equation, x equal to 1, then the only solution will be this. And hence I can say, okay, all the solutions under multiplication, that will be a group. Now let's see another equation. If I give you this equation, x is square equal to 1. For this equation, how many solutions are there? What can you say about x? You can say x equal to 1, comma x equal to minus 1. So two solutions will be there. Tell me, is this a group under multiplication? So these are the solutions. I can say these are roots of unity. I can say these are roots of unity. These are roots of unity. Okay. So tell me, is this a group? Yes, this is also a group, right? This is also group. What is the identity element? The identity element is 1. What is the inverse of 1? Inverse of 1 is 1. What is the inverse of minus 1? What is the inverse of minus 1? Inverse of minus 1. That will be minus 1. You can check. See, okay, very simple what I'm saying. So basically I'm saying that if you notice this equation you notice, then what will be x? X will be 1 comma minus 1. Now this 1 comma minus 1, this will be a group under multiplication. The identity element will be 1, and you can notice that identity element inverse will always be 1. See, identity element inverse is always identity element. This we have already seen in the last class. And what will be the inverse of minus 1? Okay, so that will be minus 1, because you can check minus 1 inverse means what should I write here such that I get 1? Tell me, what should I put here? What should I put here? I should put minus 1, right? So that's the idea. So this is a group. This is structured. This is also a group, I can say. What is the order of this group? For this group, what is the order? The order is 2. I told you order of structure means number of elements. So order of this group is 2. And order of this group is 1. The order is 1. For this group, the order is 1. Okay. Now, some interesting things. What are the solutions of this? X cube equal to 1. For this equation, how many solutions are there? How many solutions we have for this equation? Notice. For this equation, you have x square equal to 1. For this equation, you have 2 solutions. For this equation, x power 1 equal to 1. For this equation, you have 1 solution. Then for this equation, how many solutions will be there? How many solutions will be there? There will be 3 solutions. So we have 3 solutions. Okay, we have 3 solutions. Let's see what are these. Let's find out what are these solutions. Let's wait. Okay, so let's solve this. This is your equation, x cube equal to 1. Let's solve it. So what it means? It means x cube minus 1 equal to 0. One solution is 1, right? I can say x equal to 1 is the solution. X equal to 1 will satisfy. x equal to 1 will satisfy. And this is your favorite thing from your school life. Whenever you have this type of polynomial, whenever you have this type of third degree polynomial, this is your 3-degree polynomial. Now this is your favorite thing. Then what to do? If you have one solution, then what to do? How to find another solution? Write 3 times like this. This is your favorite thing from your school life. What you will do? You will write it 3 times. Yes or no? Okay, just wait. Very simple thing. This is the equation x cube minus 1 equal to 0. X equal to 1 will satisfy. If x equal to 1 will satisfy, then how to find the other thing? So write this 3 times. X minus 1, x minus 1, x minus 1. Now, what I want x cube. This is what I want x cube. So what should I multiply with this? What should I multiply? If I want x cube, then I should multiply x square, because I want x cube. Now, if I do this, then what I got? From here, what I got x cube minus x square. Do I want x square? Do I want x square? I don't want x square. So I should multiply this with x, so that it will create x square minus x. So this x square will cancel. Now, do I want x? Do I want x? No, I don't want x. Then what I will do? Now this x will cancel. So finally I got. Finally I can say this is what I got. So I got what? I can say x cube minus 1. X cube minus 1. This is same as x minus 1, x square plus x plus 1. Okay. So this is equal to 0. Now from here, x will be equal to 1 or x square plus x plus 1 will be equal to 0. From here, this is your quadratic equation. From here, what will be x? That will be minus b plus minus under root b square minus 4ac upon 2a. Agree? This is your quadratic equation. This is the quadratic equation. So from here, x will be minus b plus minus under root b square minus 4ac divided by 2a. Okay, so this will be the value of x. So finally, what x you have? So finally, this is what you have. So if I give you this equation, x cube equal to 1, then what will be the 3 solutions? There will be 3 solutions. This solution will be there. 1 plus this solution will be there. Okay, so this will become minus 1 plus minus this divided by 2. Okay, so what you got? So let me just tell you. So what you got x equal to minus 1 plus minus under root minus cube minus 3 divided by 2. Here, remember this I can write as like this, and this is written as iota. This is written as iota. This I means iota. Okay, so basically this I can write as under root 3 iota. Like this I can write. Okay, so this thing is iota. This is square root of minus 1. This is called iota. This means iota. Okay, iota. So it simply means iota. Iota means square root of minus 1. So from here, what I got minus 1 plus minus iota root 3 divided by 2. So what are the 3 solutions? So what are the 3 solutions? The 3 solutions are like this: iota root 3 divided by 2, 1 minus iota root 3 divided by 2. Agree or not? Is it clear? See, no one will ask you this in the GATE exam. I just wanted to tell you these are very basic things from your school life. Okay, just for nostalgia. Okay, if you can forget about it, because these are not important for our GATE exam, but these are very simple things from our school life. So if I give you this equation, then it means x cube minus 1 equal to 0. Then this x equal to 1 will satisfy. Because x equal to 1 will satisfy, so you can find out that x cube minus 1, this will be equal to this. So from here, either this is equal to 0 or this is equal to 0. If this is equal to 0, means x equal to 1. If this is equal to 0, it means you can apply this formula, quadratic equation formula you can apply. And what will you get? This quadratic equation formula you can apply, right? So what will you get? You will get -1 plus minus square root of -3 by 2. And this is iota, square root of -1, that is iota. So finally, this is what you got. X equal to -1 plus minus iota root 3 divided by 2. Okay. Now let me tell you, this people write it as omega and people write it as omega square. Okay. And this is your one. So what people do? People write this as omega and write this as omega square. Very simple. Or you can write this as omega square, or this, like, it does not matter. So you can write this as omega square, you can write this as omega, it does not matter. Okay. Basically, one of them is written as omega, another is written as omega square. So this is one. If I am writing this as omega, then it will be omega square. This is how people write. Okay. This is how people will write. So finally here I can say that x will be equal to 1 omega square. So these are the solutions. So what I am saying, finally, this is the final conclusion. So if I give you this equation, x cube equal to 1, from this equation, what will be the solutions of x? What will be the solution of x? That will be 1 omega square. This means omega. 1 omega square. This will be the solution. This is the value of omega. This is the value of omega square. If anyone asks you what is omega, this is the value of omega. This is -1, right? Sorry, this is -1. -1 plus iota under root 3 by 2. This will be the value of omega, and this will be the value of omega square. So this is the final point, that if you have this equation, then this will be the solution. Okay, now let me tell you some properties are there. Okay, some properties we have. One property is 1 plus omega square, that is equal to 0. And another property is omega cube is equal to 1. Why this property? Can anyone tell me from where this property will come? Can anyone tell me from where this property will come? Just add all of them. If you add all of them, this is 1, this is omega square. If you add all of them, what will you get? Add all of them, what will you get? You will get 0. If you add all of them, you will get 0. Just add all of them. You can check it out. Very simple. This is very simple. If you add all of them, you will get 0. You can try to add. So 1 plus omega square will be 0. And omega cube will be 1. Why omega cube is 1? Because x equal to omega. Because x is equal to omega, right? Because you can, this omega is x. So I can say, if you put x equal to omega, then omega cube will be 1. Very simple. Is it clear? These are called cube roots of unity. Let me tell you. These are called cube roots of unity. These three. These are cube roots of unity. Unity means 1. Unity simply means 1. So these are the cube roots of 1. Okay. So far, is it clear to everyone? Is this clear so far? If you have any doubt, then you can just take this. This one you can take. These three properties you can remember if you have any doubt. But everything is very simple. But this property you can take, that if x cube equal to 1, then from here x will be equal to 1 omega square. And these properties you remember. 1 plus omega square will be 0. And omega cube will be 1. These two properties. Okay. Now tell me, is this a group? My question is 1 omega square. These are the cube roots of unity. This multiplication, is this a group? Yes, this will be a group, because multiplication is associative. This multiplication will be associative. You can notice this will be closed. You can notice this will be closed. If any two elements you take, you multiply them, then you will get the third element. Any two elements you can take. For example, if you take these two elements and you multiply them, then what will you get? You will get this, and this is in the set. So any two elements you take, If you multiply them, then what you will get? You will get another element from the set. You can multiply any two elements. Any two elements you multiply, you will get another element in the set. So you can notice all the results. All the results are in the set. All the results are in the set. So I can say this is closed. Okay. Next, if you multiply omega square dot omega square, what that will be? That will be omega power 4. That will be omega cube multiplied by omega. That will be omega. Omega cube is 1. Okay. Is it clear? So omega power 4 will be omega because omega cube is 1. So omega power 4. Remember these. For example, if I ask you what is omega power 4, that will be omega cube into omega. So that will be omega cube is 1. So that will be omega. Can anyone tell me what is omega power 10? That will be omega power 9 into omega. And this omega power 9, this is a, so this will be. Can anyone tell me what will be omega power 50? What that will be? That will be omega power this equal to, okay, so that will be omega square. So like this you can find. Very simple. Okay, so is this a group? Yes, this is associative because multiplication is associative. Multiplication is always associative. So this is associative. Closure properties we also have. What is the identity element? Here, what is for multiplication? The identity element will be 1. The identity element is 1. Now, what is the inverse? What is the inverse in this 1 comma w square comma multiplication? In this structure, what is the inverse? Like, what is the inverse of 1? What is the inverse of 1? The identity element inverse will always be identity element. Identity element inverse is always identity element. What is inverse of w? Means omega. Omega inverse means what should I write here such that I get 1? Tell me, what should I write? What such that I get 1? I should write omega square. Okay, I should write omega square. And what will be the inverse of omega square? Basically, what should I write here such that I get 1? So what should I write here so that I get 1? I should write omega. So omega inverse will be omega square. Omega square inverse will be omega. Very simple. Is it commutative? Is this commutative? Yes, because multiplication is commutative. So finally, 1 omega square multiplication. This is a abelian group. This is a group. This is a abelian group. And the identity element is 1. Okay, so very simple. Is it clear to everyone? Remember, these are called cube roots of unity. You can call them cube roots of unity. Cube roots of 1. Why we call them cube roots of 1? Because from this equation we are getting this. Why we call them cube roots of 1? Because we are getting this from this equation. So here x is equal to 1 power 1 by 3. That is the reason. That is the reason these are called cube roots. This is called cube root. Cube root of 1. So this is the reason. Okay. So we call them cube roots. These three are called, these three people, 1 omega square. These are called cube roots of 1. Now we have already found, remember, now we can also find x power 4 equal to 1. What are the solution of this equation? Anyone want to tell me what are the? There will be 4 solution. There will be 4 solution. See, x equal to 1 will satisfy, right? X equal to 1 will satisfy. X equal to minus 1 will satisfy. X equal to 1 will satisfy. X equal to minus 1 will satisfy. X equal to iota will satisfy. X equal to minus iota will satisfy. How? From where we are getting this? Because remember, this x, what is this? This means what? This simply means x power 4 minus 1 is 0. And what this means? Can anyone tell me? This means x square plus 1. X square minus 1 is equal to 0. This is your favorite formula. A square minus b square is equal to a plus b, a minus b. Okay, so this is your favorite formula. So x power 4 minus 1, that will be x square plus 1, x square minus 1 equal to 0. If this is 0, from here what can you get? So from here you can say x square is equal to 1, and x square is equal to 1, so x will be plus minus 1. And from here what will you get? X square is equal to minus 1. X square is equal to minus 1. So x equal to iota, x equal to minus iota. From here I can say x equal to iota minus iota. So I can say x equal to iota comma minus iota. Okay, so very simple. So this is a simple thing. So for this equation, these will be the solutions. What we call them? What is the name for them? Because they are coming from this equation. They are coming, these people, these four people are coming from this equation. So what we call them? We call them fourth root of unity. Fourth root of unity. So these are fourth root of unity, quad root of unity or fourth root of unity. So this is the point. Is this a group? So this is the set 1, minus 1, iota, minus iota, multiplication. Remember some properties of iota. You should remember the properties of iota. What are the properties of iota? First of all, iota is equal to square root of minus 1. So what iota square will be? What will be iota square? Minus 1. So what will be iota cube? So what will be iota cube? That will be iota square into iota. So that will be minus iota. What will be iota power 4? That will be 1. Because iota power 4 means iota square into iota square. And iota square is 1, minus 1. Iota square is minus 1. So this will be 1. So iota power 4 is 1. Iota power 4 is 1. So what is iota power 18? Iota power 18, that will be iota power 16 into iota power 2. This is 1. So you will get iota square. So this is 1. This is 1. And what is iota square? Iota square is minus 1. So finally it will be minus 1. Okay. So these are very simple things. These are the properties of iota. Is this a group? So this multiplication is definitely associative. Multiplication is always associative. And the closure property, this is closed also. Why this is closed? Any two elements you take, the multiplication will be inside. If you take any two elements, then the multiplication will be here. For example, if I take these two elements, then what will be the multiplication? If I take these two elements, then what will be the multiplication? Multiplication will be minus 1. Okay. So if you take these two elements, the multiplication will be minus 1. Okay. So this is closed. This is associative. And what is the identity element? Identity element of multiplication is 1. This is the identity element. And what is the inverse? Let's find out what is the inverse of 1. Inverse of 1. That will be 1, because identity element inverse is always identity element. Okay. What is the inverse of minus 1? What is the inverse of minus 1? Means what should I write here? What should I write here so that I get 1? What should I write here? So I should write minus 1. Okay, so minus 1 inverse will be minus 1. I can say minus 1 inverse will be minus 1. Let's find out the inverse of iota. What that will be? It means what should I write here so that I get 1? Tell me what should I write here so that I get 1? I want 1. So I should write minus iota. So I can say iota inverse will be minus iota. Similarly, minus iota inverse will be iota. Okay. So this is the point. So I hope all of them are clear. So what we have seen, this is the conclusion. So what we have seen so far, let's find out. So you can notice all the properties are satisfied. So this is a abelian group. So I can say this structure, if you notice this structure is abelian group, because this is commutative. Multiplication is commutative also. You know that multiplication is commutative. Okay, now this is the conclusion. Remember, First, we have seen that this equation will give you what x? This equation gives you this x. Okay, this equation will give you this x. So this is, so this equation will give you this x, and let me tell you that this under multiplication, this will be a abelian group. Agree? Next, second, this equation will give you what x? This equation will give you 1 comma minus 1. This equation will give you 1 comma minus 1. And we have already seen this is also a abelian group. Because this equation, remember, because of this, we call it two roots of unity. These are called two roots of unity. These are simply called two roots of unity. Okay, because of this, or I can say simply roots of unity. So these are the two roots or roots of unity. So this is also a abelian group. Also, we have seen that this equation, what it will do, this equation x cube equal to 1. From this equation, what will you get? What x will you get? You will get 1 omega omega square. This is what you will get. This under multiplication, this is also a abelian group. We have also seen this is also a abelian group. What these are called? These three people, what they are called? These are called three roots of unity. Means cube roots of unity. Unity means 1. Okay, because x is equal to 1 power 1 by 3. So that is the reason we call them cube roots of unity. So these are called three roots of unity. Similarly, fourth thing, if I take x power 4 equal to 1, from this equation, what x I will get? I will get 1 minus 1 iota minus iota multiplication. Under multiplication, this is also a abelian group. Under multiplication, this is also a abelian group. And these four people are called four roots of unity. These are third root of unity. These are second root of unity. So these are third root of unity. And these are fourth roots of unity. These four people, because x is equal to 1 power 1 by 4. So that is the reason we call them fourth root of unity. So can you make one observation? Okay, can you make one observation that and for any value of n, this will happen. Okay, so this is the final general thing. For any value of n, so this is the node. Okay, for all n greater than equal to 1, for all n greater than equal to 1, nth roots of unity, okay, is a abelian group under multiplication. Is a abelian group under multiplication. Okay, so for all n, whatever n you take, for all n, whatever n you take, nth roots of unity is a abelian group under multiplication. What it means? If I give you this equation, x power n equal to 1, if I give you this equation if I give you, then the roots will be like this. I can say the roots will be, 1 will be the root. I can say that roots will be 1 theta square and so on. What will be the last? What will be the last? What is the last? The last is n minus 1, because there will be n solution. For this equation, there will be n solution. For this equation, there will be n solution. So I can say, if you have any equation, x power n equal to 1, if you have any equation, then these are called nth roots of unity. These are called nth roots of unity. And they will create a group. Okay, so they will create this will be a abelian group. This will be a abelian group under multiplication. This will be a abelian group under multiplication. So that's it. Anyone has any doubt? Is it clear? See, all of them we have done. Like this 1 omega omega square we have done, 1 minus 1 iota minus iota, this we have done. So similarly, similar observation will tell you that for all n equal to greater than equal to 1, nth roots of unity is a Abelian group under multiplication. So, okay, whatever. So for this equation, the set of all solutions, this is your equation. For this equation, set of all solutions will create a Abelian group under multiplication. So this is the point. I hope this point is clear to everyone.